The ideal gas law is the law that we use to help us explain the behavior of an ideal gas. An ideal gas is simply a gas that behaves ideally. But what does that really mean? Well, if a gas behaves ideally, then that means it behaves in a way that we would predict it to behave based off the various gas laws. For example, we know that if we increase the temperature of a gas, then the volume of the gas will also increase as long as the pressure remains constant. This is known as Charles' law. We also know that if the pressure on a gas is increased, the volume of the gas will go down as long as the temperature remains constant. And this is known as Boyle's law. We have covered the relationship between pressure, volume, and temperature in the various gas laws in other videos. If you need help with those, make sure to check those out. I'll also link them in the description. It is important that you understand the relationship between pressure, volume, and temperature of a gas before you dive too deeply into the ideal gas law. Welcome back to the channel, where our goal at Tadashi Science is to make science simple. If you haven't already, make sure to subscribe so we can help reach more people and further help you on your science journey. So we know the ideal gas law describes the behavior of an ideal gas. And remember, an ideal gas is simply a gas that behaves ideally, or as we think it should behave based on the inverse relationship between pressure and volume, and the direct relationship between temperature and volume, and temperature and pressure. When we take all these things into consideration, we can then derive the ideal gas law formula, which is PV equals nRT, where P is pressure, V is volume, N is moles, R is the ideal gas law constant, and T is temperature. Before we look at solving practice problems, we first need to look at the ideal gas law constant in more detail. The ideal gas law constant is a number that we have to use when solving the ideal gas law formula. Essentially, what this number does is it takes the relationship between pressure, volume, moles, and temperature and gives us a formula we can solve. Based on the other gas laws, we know that PV is proportional to NT, but we cannot solve this as it is not an equation. There is not an equal sign, so we cannot solve for anything. The ideal gas law constant, when plugged into the right side, allows us to change the proportional symbol to an equal sign, and this allows us to solve for a specific variable. The ideal gas law constant is a value that we always know. Even if it is not given in the problem, we always know what number to use. So you might be thinking, well, what number do we use for R? And that answer is, it depends. There are different R values we can use, and this depends on the units that you are using when solving for pressure, volume, and temperature. The two main values we use, or the ones that are more common, are 8.314 kilopascals times liters divided by moles times Kelvin, or 0.0821 liters times ATM divided by moles times Kelvin. There are other values that can be used, so make sure to check with your teacher as to what values you are expected to use and know how to use in your class. You can see that the main difference between the units on the R values is pressure. For 8.314, the pressure is kPa, or kilopascals, whereas for 0.0821, the unit for pressure is atm, or atmospheres. Volume is liters for both, and temperature is Kelvin for both. So you can look at the units on R to help you know what units your other variables need to be in when solving the ideal gas law formula. For example, neither R value has temperature in Celsius, so all temperature values have to be converted to Kelvin. You can also see that the volume for both R values is in liters, so all volume values have to be converted to liters when using either one of these R values. So now that you know the ideal gas law formula, and you know what R value to use, let's look at some practice problems. The key to solving gas law problems is to be able to know what variable each number in the problem represents. This will help you plug the correct number with the correct variable when you solve your equation. So when I read the problem, the key thing you need to look for is the units attached to each number. So when I read the problem, I see that I have 1.9 moles of a gas. Moles is represented by the variable N, so we'll plug in 1.9 for moles. That gas is held at a pressure of 5 atm. It tells me atm, so I know atm is pressure, so I'm going to plug in 5 atm for P. It is in a container with a volume of 50 liters. Liters is the unit for volume, so I know to plug in 50 liters for V. And the question is asking me what is the temperature of the gas, so I know I'm solving for T. Remember that the R value is always a known number, So even though the problem doesn't give it to you, we know that we need to use the ideal gas law constant. I'm going to use 0.0821 for this problem because my pressure is in ATM, my volume is in liters, my moles are in moles, and that means the temperature when we solve for it will be in Kelvin. So all I'm going to do is plug the numbers into the equation. For P, I'll plug in 5. For V, I'll plug in 50. For N, I'll plug in 1.9. And for R, I'll plug in 0.0821. I'll leave T as it is because that's what I'm solving for. So I can solve for T and isolate it by dividing both sides by 1.9 times 0.0821. And when I do that, I get a final temperature of 1602.67 Kelvin. So now that you've seen the problem worked out for yourself, pause the video now and see if you can answer this question. Once you're done, come back and check your answer. So again, we're going to read the problem and pull out each number and match it with a variable. It tells me I have an unknown quantity of a gas at a pressure of 1.2 atm. So I'll plug in 1.2 for atm. It tells me I have a volume of 31 liters, so I'll plug in 31 for V, and a temperature of 87 degrees Celsius, so I'll plug in 87 degrees Celsius for C. It is important to remember, though, that the temperature cannot be left in degrees Celsius and has to be converted to Kelvin. And in order to do that, we're just going to add 273 to 87 to get a Kelvin temperature of 360. The question then asks how many moles of gas do I have? So this tells me I'm solving for N. Again, I'll use my ideal gas law constant 0.0821 because my pressure is in atm. So I can plug my numbers into the equation. I'll plug in 1.2 for pressure, 31 for volume. Moles I'll leave as N because that's what I'm solving for. I'll plug in 0.0821 for R and 360 for T. When I solve for N, I then get a final answer of 1.26 moles. Hopefully now you better understand how to solve the ideal gas law formula. If you enjoyed this video, here's another video you might find helpful. Thanks for watching, and if you haven't already, make sure to subscribe as we produce new science videos every month.